Here once again we'll discuss delays in network. There are four kind of delays: processing delay, transmission delay, propagation delay, and queuing delay. So one by one we will discuss about these delays through this example. So here these two nodes wants to communicate using this network, and in middle of these nodes and the node B, there is a node A. So these A and B are router nodes. Their job is to reroute the packet towards the destination. So whenever any node wants to communicate, it will frame a packet and it will start transmitting those packets initially. So once it will start transmitting those packets, transmission means it will start pushing those bits over the wire. How it will push the bits over a wire? Suppose if the packet comprises of 10 number of bits, 10 bits are there in one packet, and it has to share it with the node B. This node has to share that thing with node B. So obviously it will use this path. First, it will start sending those packets to node A. Node A will reroute it to node B. So that is the path of, okay. Now we'll calculate the delay in occurred while transmitting or while sending. It's not right word, though we use interchangeably the word transmission, transfer, and all, but it is not the right word. So the right, it is precise to say that while sending the packet from source to destination, there come several phases which are the part of delay. The first phase is transmission. So this node will start transmitting the data. Transmitting, you can always relate transmission with signals because we transmit the signals. So in the same way, we can understand the transmission delay. So suppose a packet there at this node comprises of 10 bits. So it has to put 10 bits over the wire, because until and unless this node will put the packet over the wire, it's not going to propagate. So the time spent to push all the 10 bits over the wire is called transmission delay. So obviously it's not going to push bit, it is obviously convert those bits into signals. So signals would be pushed over the wire. So modem will do that part. So digital to analog conversion will take place, and then electromagnetic signals would be put over the wire. So how long? So suppose a packet comprises of 10 bits. So how long uh, that sender would take to push all the 10 bits over the wire in terms of its electromagnetic equivalent signals? That is called the transmission delay. Once everything is on up on the wire, then it will start propagating. Obviously signal will propagate over the wire. Signal will propagate over any medium through which these two nodes are connected. So once it will start propagating, that delay which occurred during propagation is called propagation delay, and that depends on the speed through which it is propagating and obviously the distance. Then once it reaches at the node A, obviously node A has to process it. Node A has to process it and figure out where it has to reroute it. But the node A's processor at that time may be busy, so it has to wait for a while. Where it will wait? It will wait inside buffers. So once the node A receives the packet at its interface, the packet will find place inside the buffer. So how long it will remain there before processor picked it for processing, that time which it spent, the packet spent inside buffer, is called the queuing delay, because that is the queue, because it follows the first in first out mode. So first whatever comes will find the processing time first. So first in first out. So that's why it's a queuing delay. It's the node A has to maintain a queue, and as and when it will receive the packet from the incoming nodes, it will keep pressing those packets inside that queue, and the processor will keep pulling those information, process it, and then reroute it. So once again, for rerouting means once again it has to retransmit it. So transmission delay, then the propagation delay, then once it will come here, it has to process it and then channelize it up the layer. So in particular, if there is any intermediate node, any router for that matter, so it there the packet occurs four types of delays: queuing delay, processing delay, transmission delay, and propagation delay. If there are n number of routers in between, so these delays gets multiplied by that number, by that count, how many times these type of delays will happen till the time finally that packet reaches the destination. So that is all about the delay concept. Here, one more thing I want to introduce about the packet loss, that why generally loss happens, because at this node A, the queue size is limited, and it may be possible the incoming speed, the incoming transmission, these transmission speeds of these two devices may be more than the transmission speed of this A. By the speed it is retransmitting the packet, the node A is retransmitting the packets on its outgoing interface, the speed at which the arrival is happening is much more, so there is a mismatch. So because of that, if those packets start accumulating inside buffer, and there comes a situation when it gets exhausted, and then it start overflowing, and that overflowing will happen in terms of that results into packet loss. Now we will understand all these things through example, through numerical example. So for that purpose, I'm using Stalling's example. William Stalling, there's a book. I'm using their example. So before discussing their example, one more important thing is the term bandwidth. What is bandwidth? So we'll discuss the bandwidth in brief. Uh, Hope you will be able to appreciate and understand the bandwidth, because then only we can move ahead and can understand those examples much better. Bandwidth in two ways you can understand. One, bandwidth is attributed to a channel or the link which connects one hop to the another hop. So that link capacity is termed as bandwidth. So in terms of analog, when we have to understand, then bandwidth we calculate in terms of hertz. So the range of frequencies which that channel can hold and can pass through it. So every channel, every medium, every link media which connects two nodes, which connect two hops, can pass certain range of frequencies. If we are using copper wire, it has certain frequency range which you can pass through it. Beyond that frequency range, if you will try to pass it, it will not reach the destination, it will not reach the next end of the copper wire. So every medium is associated with a range of frequencies which it can support, which it can pass through it. So that range is called the frequency bandwidth, that we calculate in terms of hertz. When we have to calculate it in terms of bits per second, its digital equivalent, that is called the bits per second. The transmission speed, That is called the transmission speed. The second is in bits per second. So what is the transmission speed which that medium can withstand? How many bits per second transmission it can withstand, the medium can withstand. Copper has different value in terms of bits per second. Fiber optics has different values. So it depends on the media that media can withstand that much transmission speed that we calculate in terms of bits per second. Though there is a relationship, because transmission is what, when you will transmit, you will convert your signal into electromagnetic waves. So what is the speed at which you can generate those electromagnetic signals which your medium can withstand? So from there comes how many bits per second you can transmit over that wire. So that is the second way of understanding, and it is so for electronics people, those who deal with electronics, they generally deal it in terms of its analog frequency bandwidth. But as a computer and network engineer, people generally attribute a wire or any medium in terms of its bits per second as bandwidth, and that is also referred to as a capacity of that channel. What is the capacity? What is the maximum bits per second transmission speed that wire or that channel or that medium or that media can withstand? That is called the bandwidth. So in two contexts I've explained you, one is the analog context, another one is the digital context. Then we will understand, suppose so there is a subscriber line. Subscriber line means a telephonic line, which is nothing but a copper wire, is 4 kilohertz. So the range that frequency bandwidth, how you calculate is highest frequency minus lowest frequency that medium can withstand. When you take the difference of it, the difference is 4 kilohertz for voice or data. The bandwidth of this line for data transmission can be up to 56,000 bits per second. So when you will use the same media, in two ways they have explained the bandwidth. One is the frequency range which the medium can withstand, that is the 4 kilohertz for both voice and data. Once you will start using it for data transmission, the transmission speed you can withstand over it is 56,000 bits per second using a sophisticated modem. Modem obviously have to convert analog to digital signal. Then if you will improve the bandwidth, so if you will improve the bandwidth in terms of the frequency range, obviously then you can send more number of bits per second using the same technology. Here there's an example, a network with bandwidth of 10 Mbps. So you can transmit maximum 10 megabits, 10 into 10 raised to the power 6 bits per second, and it can pass only an average of 12,000 frames per minute. You can pass only, there are 12,000 frames per minute, and each frame comprises of 10,000 bits. The frame you can consider as packet. This terminology we will understand that the same packet has different terminologies all across the stack, all across the layers. So this frame, so 12,000 frames per packet, with each frame carrying an average of 10,000 bits. What is the throughput of this network? Now, one is the bandwidth in terms of bits per second. That is nothing but the transmission rate at which you can send, that medium can withstand. Now there is one more important parameter. These are all the performance parameter. Throughput. What is the throughput of this network? Throughput is nothing but seriously from source to destination in 1 second how many bits are reaching. Though the medium is supporting, the medium is supporting some sort of a transmission rate, that is 10 into 10 raised to the power bits per second. You can transmit that many things, but there are several other constraints. you have to frame a packet. That also require time. That also at your sender system you require processing time to frame your frame, to frame your packets. Then you will convert it into signal, then you will start transmitting it over a wire, and then finally those all bits will reach the destination. So in 1 second, how many bits are reaching the destination finally? That is called the throughput. So here, when we start calculating the throughput, how we'll calculate? There are 12,000 frames we are generating in 1 minute, and each frame comprises of 10,000 bits. So total number of frames which we are sending in 1 minute is 12,000, and 12,000, each frame comprises of 10,000. So 12,000 into 10,000, and these many bits we are sending all across the network to the destination in 60 seconds. So in 1 second, how many bits we are sending? 2 into 10 raised to the power 6 bits per second, 2 Mbps. Though the bandwidth is 10 Mbps, but we are not utilizing that bandwidth to its fullest. Though the capacity is there, but the throughput is less. Throughput is generally less because throughput not only depends entirely on the bandwidth, throughput depends on several other parameters. It depends on delay, because when you will delay the packet, obviously the time at which you are delaying it, you are waiting for some other thing to happen before transmitting it. You could have sent several other packets also. So throughput is always less. That depends on delay. If you will decrease the delay, obviously your throughput will increase, because here in 1 minute, in per minute, 12,000 packets you are framing and then sending it. So obviously if per minute the rate at which you are generating the frames will increase, obviously you can increase the throughput. But the throughput, if the maximum bandwidth is 10 Mbps, your maximum throughput can go up till 10 Mbps. Beyond that, because that is the maximum transmission speed. If there will be no delay and you're generating packets, you're generating frames, so as to match up with the transmission speed as well. So in that extreme situation also, your throughput would be maximum 10 Mbps in this situation. Or in general way, your throughput can only attach, or a ceiling it can hit, which will be decided by the bandwidth of the channel. So the maximum it can go to what is the bandwidth of your channel. Then the next example, the propagation speed. You know, the propagation speed depends on, once you have pushed signal over the wire, it will start propagating, and depending on the distance, then it will reaches there, it will start propagating, and then after propagation it will reach the destination. So that is called the propagation speed. Transmission, you know, transmission. In other way, how you can understand the transmission delay? Propagation delay you understand, because that is depends on the distance upon the speed of the signal. Distance in between source and destination divided by whatever be the speed of the signal. How in other way we can understand the transmission delay? So suppose transmission delay, you have pushed, suppose there are 10 bits in one packet, and we have to calculate the transmission delay. So first, corresponding to first bit, your modem would generate a signal, will push it over the wire. So now your first bit in terms of its signal is up on the wire. It will propagate, it will reach the destination. So if it is reaching the destination at time t1, after that you will push the second signal, then the third signal, then the fourth signal, then the fifth signal, then the sixth, seventh, eighth, ninth, and 10th. So once you have pushed 10th signal will also propagate and reaches the destination at time t2. So the delay in between, t1 minus t2, or that absolute difference in between T2 and T1 will be the transmission delay. In other words, how we can understand, suppose at time T1 you have pushed the first bit in terms of its signal over the wire, and at time T2 you have pushed the 10th bit over a wire. So the difference, the absolute difference in between T2 and T1 is nothing but the transmission delay. After transmission delay starts the propagation delay. Once it reaches at the intermediate node, then the queuing delay happens, and once the packet being processed, then processor will take time. That is called the processing delay. How we can calculate the transmission delay? So every channel comes with its capacity, the maximum transmission capacity, that how many signals you can put over a wire in 1 second. What is your, in terms of bits per second, how many bits you can push over a wire in 1 second. So that is called bandwidth, bits per second. What is the maximum bandwidth of your channel? So, and depending on the message size. So if the message size is L number of bits, in one packet there are L bits, and you have to calculate its transmission delay. So obviously we will calculate, because if R is our bandwidth in terms of bits per second, transmission rate, then R bits per second. In 1 second, we can push R number of bits. Now the packet size is L. So in how many seconds we can push all the bits over the wire, that is L by R. So if we will calculate the complete latency from starting till the end, then in that first comes the transmission delay, then comes the propagation delay, then comes the queuing delay, and finally the processing time. There's one more example, that what is the propagation time. Here we are calculating the propagation time if the distance between the 2 points is 12,000 kilometers. So that is the same distance. So here they have given an analogy here also, that over the Atlantic wire. So if there is a direct cable which is connecting one end of the Atlantic Ocean to the next another end of the Atlantic, so that is the 12,000 kilometer. And the propagation speed is 2.4 into 10 raised to the power 8 meter per second in cable. So how we can calculate? Simple enough, 12,000 kilometer distance upon speed, that is 50 milliseconds. So 50 milliseconds, so just in millisecond, a packet means your packet can reach us, or the electromagnetic signal can reach from one end of the Atlantic to the another end. Then what are the propagation time and the transmission time? So both times we have to calculate here, propagation delay and transmission delay. For a 2.5 kilobyte message, so consider it as an email message. If you're sending an email from one location to another, if the bandwidth of the network is 1 gigabyte per second, bandwidth means transmission speed. What is the transmission rate? That is 1 gigabyte per second, means 10 raised to the power 9 bits per second. So in 1 second, we can push 10 raised to the power 9 bits per second over a wire. Assume that the distance between the sender and receiver is 12,000 kilometers, and the light travels at the 2.4 into 10 raised to the power 8. Now we'll calculate what is the propagation time. 12,000 kilometers. So convert it into meter and divided by the speed, that is 50 milliseconds. What is the transmission speed? This is the size of the packet is 2.5 kilobyte. So 2.5 kilobyte, byte you have to convert into bit into it, and kilo means 10 raised to the power 3. So 2500 into 8 number of bits you have to push over a wire, and the speed at which you can push over the wire is 10 raised to the power 9. So divided by 10 raised to the power 9, we will get 0.020 millisecond. So here you can see that propagation time is dominating in comparison to the transmission time. So if sometime you can even ignore if your message size is too small, at that time while calculating the total delay, while modeling the total delay, you can always omit, you can always neglect, because it is negligible in comparison to 50 millisecond. It is not dominating. Then the next come where we are sending the image, not a message, not an email message, and the image size is 5 megabyte, and the bandwidth is also less. There the bandwidth was more, but here the bandwidth is less. Here you can send only 10 raised to the power 6 bits per second. There we could have sent 10 raised to the power 9 bits per second. We could have pushed 10 raised to the power 9 here, but in comparison to 10 raised to the power 9, 10 raised to the power 6, and the distance and everything is same. So once again we will calculate it is 50 millisecond, whereas the transmission time is, because the packet size here increases in comparison to the email size, its image, and 10 raised to the power 6 it also decreases. So there it was 10 raised to the power 9. So here it is comparable, here we can't ignore it. The point is, because here the bandwidth is less and the packet size is more, so the transmission will take more time then, so it is more or less comparable with propagation delay. So all these things matters while calculating the total delay. Then finally, the bandwidth delay product. Bandwidth, bandwidth in terms of how many bits we can push over a wire in 1 second. That is called bandwidth, or the transmission speed. So bandwidth and transmission speed are correlated. Here we'll calculate the bandwidth delay product. So there is a delay from sender to receiver. So certain delay is there, and that delay, when you will multiply with its bandwidth, it will give you a bandwidth delay product. In other way, if you have to just relate and understand it, bandwidth delay product is nothing but a numerical value, some value which fills the entire channel. The number of bits, the numerical number of bits, the number of bits which fills the entire channel. What is that count which fills the entire channel? That is called the bandwidth delay product. So here the bandwidth is 1 bit per second. That means in 1 second you can push one wire, 1 bit over a wire. So after 1 second, sender has pushed first bit. So first bit will then start moving ahead. So after second, first bit has moved. So it has propagated for 1 second duration. Till that time, sender has pushed the second bit also. So second bit is just behind it in terms of signal. So the first signal has reached here. Second signal has just started. After third second, sender will start generating third signal. And till that time, first signal is here, second signal is here, and third signal has just started. After 4 seconds, sender will once again push the signal corresponding to the fourth bit, and till that time, first bit is here, second bit is here, third bit is here, fourth bit is here. After 5th second, sender once again will push the 5th. Till that time, first has almost reached the receiver. When it has almost reached the first bit of the first packet, though it is a bit itself, so once that bit has reached the receiver and it has filled, so all these 5 bits have filled the channel entirely, that is called the bandwidth delay product. Okay. So here it is 5 bits. Bandwidth delay product is 5 bits. So we can think, we can understand it in that way also, that the link between 2 points as a pipe, where the cross section of that pipe represents the bandwidth, and the length of that pipe, the cross section of that pipe is the bandwidth, and the length of the pipe is the delay. So the volume is what referred to as a bandwidth delay product, because length and this cross section, when you will multiply, it will give you the volume of the pipe. So volume of the pipe is the bandwidth delay product. So here more or less the example is same, but here the bandwidth they have changed. So when you will increase the bandwidth, so obviously more number of bits can then come and fill uh, the network, means the channel. So it is also one of the performance parameter. If the value is more, if the value is more, if the bandwidth delay product value is more, that means the capacity of that channel is more. It can hold more number of bits at a time. Before reaching at the receiver, you can transmit more number of bits over, and you can push more number of bits over the wire. And maximum you can push, you can generate to maximum in correlation with the bandwidth. So if the bandwidth is 4 bit per second, the maximum throughput you can achieve is 4 bits per second. Beyond that, throughput is not possible if the channel bandwidth is limited at 4 bits per second. So bandwidth is a limiting factor. Well, so that's what I have explained. The bandwidth delay product defines the number of bits that can fill the link.